So in this example, we want to determine if the function x over x squared minus 1 is continuous at x equals 1. How do we do this? Well, let's think about what it means to be continuous. So we talked about how we know it's continuous if the graph has no breaks. Well, let's break down kind of the components that you need to have for there to be no breaks. Well, you need, first off, like at any spot on the graph, there needs to be a point. That's the first thing we need. So that's the first thing I'm going to check on this function is at 1, is there actually a point? Then the other things that we want to check is we want to see on either side of this, on the left side and on the right side, do those sides meet up with our point? If all of these things happen, there's a point and the sides meet up with it, then that means that there's no break here, and so we must be continuous. So what we're going to do is try to figure that out for this example. So the first thing we're going to check out is there a point? And to do that, I'm just going to plug 1 in and see, does my function have a value at that point? So if we plug 1 in, we'll have 1 over 1 squared minus 1, which is 1 over 0. Because we have 0 in the denominator, this does not have a value. And since it has no value, that means there's no point here. So you can imagine, right, here's your graph, we've got a point missing. So that means this couldn't be continuous. So we would say f is not continuous at x equals 1.